my name is Reynisson, and today we will be taking a look at experiment 5. So we will be taking a look at the charging and discharging of the capacitor. Hello, my name is my name is Reynisson, and today we will be looking at experiment 5. Alright, so this is our circuit. In part A, the switch here closes and we're going to analyze how the capacitor charges. And in part B, the switch opens after it has been closed for a while, and we're going to analyze the discharging process. So before the switch closes, there is no current because we can replace the capacitor with an open circuit. So there is no current flowing here, so the voltage everywhere is 0. Alright, so next we are going to want to see what happens after we close the switch. First of all, we need to find the time constant, and when we have the time constant, we can use this equation here. So we can use this equation to find the voltage across the capacitor at any given time t. So let's find the time constant. We have to multiply this resistor here with the 470 microfarad. So we'll get 22.09 seconds. So we can use the formula here where VC is 5 volts. The time constant is 22.09, and then we can find the voltage across the capacitor at any given time t. So this is our final formula for the voltage across the capacitor at any given time t while it is discharging. Alright, so here we are in Spice, and we are going to simulate our circuit while it discharges. The only difference here is the pulse is 0 everywhere, and we put the initial condition for the voltage across the capacitor. Alright, so let's simulate it. And we are going to click the node right here. And as we can see, the initial voltage is 5 volts. And it decreases here exponentially until it's almost 0 at 100 seconds. Alright, so now we're going to take so here is our circuit in Spice. Here is the voltage controlled switch, and the voltage source connected to it with a pulse here, V initial 0 and V on 1. And we are going to simulate this and going to click the node here. Okay, so here we can see that the initial voltage across the capacitor is 0 volts, and it increases exponentially. So it's almost 5 volts at the end, which was expected. Alright, so here is our circuit for the discharging process. The only thing that has changed is the pulse here on this voltage source is 0 everywhere, and we also put an initial condition for this voltage across here, the capacitor. So let's simulate, and we're going to choose this node here, and as we can see, the initial voltage is 5 volts and it decreases exponentially until it's almost 0 here at 100 seconds.